This is Algebra Lesson 9-8, Factoring by Grouping. Since we've already done some factoring by grouping back in 9-6 when I taught you how to factor ax squared plus bx plus c trinomials, this should be a fairly simple lesson to do. You can use the distributive property to factor by grouping if the two groups of terms have common factors. To factor by grouping, look for a common binomial factor of the two pairs of terms. For example, if we have x cubed plus x squared plus 2x plus 2, if I grouped those first two and last two, I could take an x squared out of my first term, and then I would be left with an x plus 1. And I could take a 2 out of my second term, and I'd be left with an x plus 1. My common factor is x plus 1, and my other factor I'm left with is x squared plus 2. Please note several things. A plus b is the same thing as saying negative, parentheses, negative a minus b, because if I ran the negative through this would become a positive a, and this would become a positive b. A minus b is the same thing as saying negative, parentheses, negative a plus b, or negative, parentheses, b minus a. Just different ways of writing the same thing. Be aware of that, because if you don't recognize those, it will be sometimes hard to factor. Okay, we're going to factor by grouping. We're going to do a little factor by grouping here. If I have 2x to the third plus 6x squared plus x plus 3, the easiest way to factor by grouping, always group first two, last two. Then if it doesn't work, we can work from there, but 99% of the time, we group first two, last two. Remember, you always want to have a plus sign between them. If not, change your minus sign. You want to add the opposite so that there's a plus sign between them. That way, if you need to factor out a negative, you'll make sure you do that. My common terms are 2x to the third plus 6x squared. I can take a 2x squared out. If I divide 2x to the third by 2x squared, I'm left with x. If I divide 6x squared by 2x squared, I'm left with a 3. In my second term, there is nothing I can take out. And remember, when there's no common factor, the common factor is always 1. So I can take out a 1, and I'm left with x plus 3. My common term, x plus 3. What am I left with? 2x squared plus 1. This should be simple because we did it so many times when we factored trinomials in the form of ax squared plus bx plus c. Okay, if we look at 4a to the third plus 10a squared plus 6a plus 15, I'm looking at that. I see no common factor, so that's the first thing my brain wants to look for. Is there a greatest common factor in this four-termed polynomial? No, there is not. So I will group first two, last two. I can take out a 2a squared, and I'm left with 2a plus 5. In the 6a plus 15, I can take out a 3, and I'm left with 2a plus 5. My common term, 2a plus 5. What am I left with? 2a squared plus 3. As you can see, we've done this many times before, so this should be very simple and straightforward for you. Let's look at number 3. X squared y squared plus ay squared plus ab plus bx squared. Again, no common terms do everything, so I'll take out the first two and last two. I can take out a y squared in my first term, and I'm left with x squared plus a. In my second term, it looks like I can take out a b, and I'm left with a plus x squared. Well, x squared plus a and a plus x squared are exactly the same thing because order doesn't matter with addition. So my common term is x squared plus a, and I'm left with y squared plus b. Now these will not factor again because they're not differences of squares, because the second term is not a square and there's no minus sign in there. Look at number 4, 5x to the fourth minus 5x to the third minus x plus 1. Nothing common to all of them. So I will change this to 5x to the fourth minus 5x to the third plus, and I'll put my negative sign in my parentheses, x plus 1. I just did that because changing this way and then trying to put the parentheses in, sometimes you lose your negative sign. On my first term, I can take out a 5x to the third. That leaves me with x minus 1. In my second term here, negative x plus 1, if I take out a negative 1, I'm left with positive x minus 1, which is what I want. There's my common term, x minus 1. Here's what I'm left with, 5x cubed minus 1. And I'm done. So factoring by grouping is not difficult. Now, the other thing we need to look like is we're going to look at what happens when we throw every type of factoring together, all mixed up into different problems. You have to learn how to factor. So when you're factoring, look for several things to help you. Always look for the greatest common factor first. Always, always, always. Then look at your number of terms. If it has 2 terms, see if it's the difference of squares, an a squared minus b squared, which will factor to an a plus b times an a minus b. If it's 3 terms, the first thing I would look for, see if it's a trinomial square. Is it in the form of a squared plus 2ab plus b squared, or is it in the form of a squared minus 2ab plus b squared? If it is, use one of those special cases. If it is not, then find the product of the last term, and it's the first term and the sum of the middle terms. Okay? So if it's 3 terms and there's no a term here at the beginning, like this one. Okay, there's no a term there other than 1. I probably shouldn't put a 0. I was just circling or something. So there's a 1 there, so I need a product of 4 and a sum of 5, so that ends up being 4 and 1. Here, on the 3x squared, I need a product of negative 45 and a sum of negative 4. And when you factor that all out, you get 3x plus 5x minus 3. If it's 4 terms, try grouping. And last but not least, the most important thing you'll ever hear is oftentimes I'll put this on the paper, factor completely, because that means sometimes you can factor more than once. So be careful with that. All right, let's take a look at some problems. We're going to factor completely. Okay, factor completely. If I look at number 1, I look at that and say, ooh, greatest common factor, 14a squared. I can take out a 14 and I can take out an a squared. So I'm left with a squared minus 1. And you might say, ooh, I'm done, but I'm not. This is a perfect square. This factors to a plus 1 times a minus 1. And of course, we still have the 14a squared that we already took out. So now it is done. Always factor completely. Make sure that when you look at something, you don't see how many terms it has and see how far you can go. Number 2, I love problems like number 2, because this is a problem that actually can be factored fairly far. Binomial. Perfect square binomial, because there's a minus sign between the two. So my a term is x to the 4th, and my b term is 1. So I have x to the 4th plus 1, which will never factor again. X to the 4th minus 1. Oh, look, that factors again, doesn't it? My a term here is x squared, and my b term is 1. So this would factor to x squared plus 1 times x squared minus 1. Will not factor again. This won't factor again. This won't factor again. This will. My a term here is x, and my b term is still 1. So that will factor to x plus 1 times x minus 1. This won't factor again, and now this won't either. So everything I've underlined is the factorization of x to the a minus 1. So it becomes x to the 4th plus 1 times x squared plus 1 times x plus 1 times x minus 1. We look at number 3, 12x to the 3rd minus 21x squared plus 8x minus 14. 4 terms, so automatically I think grouping. Right after I think greatest common factor, and I'm looking at that going, there is no greatest common factor of all 4 terms. So I'm going to group it. First 2, last 2. What can I take out of 12x to the 3rd minus 21x squared? I can take out 3x squared. That leaves me with 4x minus 7. What can I take out of an 8x minus 14? I can take out a 2. That leaves me with 4x minus 7. Here's my common term, 4x minus 7. Here's what I'm left with, 3x squared plus 2. Neither one of those factor again, so there's my final answer. Okay, let's look at number 4 here. 3x to the 4th plus 30x to the 3rd plus 75x squared. Well, I know there's the greatest common factor, at least a variable in there. But I also know that 30 is divisible by 3 and 75 is divisible by 3. So I can take out a 3 and I can take out an x squared. That leaves my first term as x squared plus 10x plus 25. Does x squared plus 10x plus 25 factor again? Yes, it does, because it's a perfect square trinomial. X squared is a perfect square, 25 is a perfect square. Square root of x squared is x, square root of 25 is 5, 5 times x is 5x, times 2 is 10x. This is a perfect square trinomial. This will factor from x plus 5 times x plus 5. And of course, we have to make sure we put down the 3x squared that we already took out of the problem. And then it is finally factored completely. Number 5, 2a to the 4th plus 14a to the 3rd plus 24a squared. Again, out of greatest common factor, I can take out a 2a squared. If I take out a 2a squared, I'm left with a squared plus 7a plus 12. Now I need two numbers that multiply together to get 12. My product is 12. My sum is 7. I'm thinking 4 and 3, because 4 times 3 is 12, 4 plus 3 is 7. So that gives me a plus 4 times a plus 3, because there's no number in front of the a squared. I don't have to factor by grouping. And then don't forget to take out my greatest common factor and put it back in. So I'm left with 2a squared times a plus 4 times a plus 3. Number 6. Y to the 5th minus 2, y to the 4th minus 35, y to the 3rd. Greatest common factor, y to the 3rd. I'm going to take out a y to the 3rd. I'm left with y squared minus 2y minus 35. So I need a product of negative 35 and a sum of negative 2. 7 and 5, I'm thinking negative 7 and positive 5. So that would give me negative 35, and that would give me negative 2. So I'm going to have y minus 7 times y plus 5, and of course my greatest common factor is y to the 3rd. And then I am done at that point in time. And I don't think I have any other problems to practice. So there we go. Just make sure that when you factor by grouping, you also factor completely. Make sure your term will not factor in. Use that little chart that I gave you to look at how many terms things are. The more you factor, the better you'll get at it. I can look at things and almost immediately know if they factor. Some people cannot. The more you practice them, the more you factor things, the better you'll get.